Hello guys, welcome to Bugs in Code. The problem that I'm going to explain today is count special numbers. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe the channel so that you get notified when I push a new video. Okay, so let's get started. Here is the problem statement and it says that you are given an array ARR of size n consisting of only positive integers. Okay, and your task is to find the count of special numbers in the array. A number is said to be a special number if it is divisible by at least one other element of the array. Okay, one example is given here. Let me explain the problem with the example. So example says that we are given an array which is having elements 2, 3 and 6. Okay, now our task is to check each element whether it is a special number or not, and then I have to return that how many special numbers are there. Okay, so for this 2, how to check special number? It is saying that if it is divisible by at least one other element. Okay, so let's check for 3 and 6. Is 2 divisible by 3 or 6? No, so 2 is not a special number. Okay, same for 3. 3 is not divisible by 2 and 6, so 3 is again not a special number. For this 3, for this 6, so this 6 is divisible by 3 as well as 2, so it is a special number. Even it is divisible by 2 only or 3 only, then it is again a special number because I need at least one element. Okay, now we can see that among all three elements I have one special number, so 1 is going to be the output here. Now I hope you guys are clear with the problem statement. Let me talk about the solution now. Okay, so the first approach that comes to mind is naive approach, which says that for each element in the array we can check. Let's take an example. So if I have an example like 2, 3, 6 and even 15, or I have 5, or I have 4. Okay, now for these elements, for each element present in this array, I am going to check whether the current element is a special number or not. How to check? For each element, I will traverse the whole array and I will find whether there exists any number which can divide this current number or not. Okay, fine. So for this, if I have to like store whether the current number is a special number or not, so I will store either in true or in false form. So true or false can be my output. So I need a boolean array. So I'll make a boolean array which is result. The type is going to be boolean, and this result is going to be storing like whether the current element at current index is a special number or not. Okay, so now I'm going to write the pseudocode. How I'm going to check? Like I will have a loop which is for I equals to 0 and I smaller than n and I plus plus. Now this loop is going to check for each element whether it is a special number or not. Now inside that I need one more loop for j equals to 0, j is smaller than n and j plus plus. Okay, now inside this loop, the first condition, because inside this loop I will check whether there exists any number which can divide this 2 or the current number that I have. Okay, so the first condition that I will check is okay, so the first condition is if my j is not equal to I. This is very important because I want elements other than the current element. Okay, and now, and is there any array of j which can divide array of I? So and if array of I mod array of j is double equal to 0 or not. So if it is the case, then in that case I will make my result as true. I will write result of I equals to true. I will say okay, it is now like this particular element or the current element is a special number. I will say true. Okay, fine. Now after that, since I need at least one element, so if I have found one element, then I can break simply. So after that I'm going to break the loop. Okay, so this is how we are going to solve this problem using the naive approach. But if you write this code, then it is going to show you time limit exceed. The reason is why. Let me tell you the reason. If I have an array like let me take an array like 1 1 1 1 2 2 2 2 2 3 3 3 4 4 4 4. I hope you guys have got what I'm going to say now. I will say that handling duplicate elements, this code will is inefficient in handling duplicate elements. Why? If I have this one and I know this one is a special number, so is there any need to check for this one again? This is my question. And is there any need to check for these occurrence of one? Because if I know one is a special number, then one is one, so one is going to be special number for every case, right? So in that case I have to handle duplicate elements. But the question is how to handle. Handling duplicate element is something which is going to be really very interesting. So let me write the heading: handling duplicate elements. Okay, now I will use a hash map. I'll use a hash map, and hash map is going to store the current element, like whether I have processed the element or not. So if like I'm done with this 2, so I'll store in the hash map like 2. First of all, I'm done with the 2 as key, and after that I'll store whether it is a special number or not. So is 2 a special number for this array? No. So I will store no here, or I'll store false here. This way, if I see 2 somewhere else, like if 2 is if I have seen 2 one more time, okay, then I will say, if I know the answer of 2, then I'll simply store the answer of 2 from the map. So I just need a map here. Now I can create a map and I can check one condition. So let me write a map. I'll create a map which is what is the type of map? It will store one integer and one boolean, right? Now this map I'll check if like map of like we write simply in map.find in C++, array of I is not equal to map.end. Like if I have already processed the current element, okay, in that case I will simply store in the result like result of I is going to be what? Result of I is simply going to be map.get or map of array of I, isn't it? So this is what I have to do, and when I do this, then I will simply be able to handle the duplicates element as well. So this is how we are going to write the naive approach. Now let me show you the code. Okay, so let me show you the code. Here is the code, and I'll start with the naive method. So on the left hand side I have the Java code, and on the right hand side I have the C++ code. Okay, now you can see that I have a boolean array here which is going to store the result for each index. Now this is the place where I am checking the condition where I have processed the current element or not. So if I have processed the current element, then I am simply going to take the answer from the map. Else I will start a loop which is again going to be an O of n loop. So it is again going to be an O of n loop. So I'm using two nested loops here, so that's why the complexity of this approach is going to be O of n square. Now at last I'm checking how many elements I have which are having true value, means which are special numbers. Okay, and you can see that I have the similar code for C++ as well. Now I hope you guys are clear with the naive approach that I have. So now let me move to the board again. Okay, so now I hope you guys are clear with the naive approach. Let me talk about the time complexity. Even let me talk about the time since you can see that if you see here, then you will find that I am using two nested loops. So the first loop is O of n, and the second loop is again O of n loop. So this way the complexity is going to be O of n square. And what about the space complexity? So the space complexity is again going to be O of n because I am using a result array and a map. Okay, fine. Now I hope you guys are clear with the brood like naive approach. Let me talk about the optimal approach now. Okay, so optimal approach is based on the Sieve method. I hope you guys know what is Sieve method. So even I'm going to give a detailed explanation. So just stay tuned. Okay, now let me write the same array that I have. It's a good example. So it is having element like 2, 3, 6, 15, 5 and 4. Okay, so let me write 2, 3, 6, 15, 5 and 4. Okay, now for this 2, let me write the multiples of 2. So if I write the multiples of 2, then multiples will be like 2, 4, 6, 8, 10, 12 and 14. Okay, now for this 3, let me again write the multiples of 3. So 3, 6, 9, 12. After that I will have 15. For this 15, let me write the multiples: 15, 30, 45, and so on. Okay, now for this 5, 5, 10, 15, and for this 4, 4, 8, 12, and so on. Okay, now you can see that, you can notice one thing, that this 6 can never be a special number. Why so? Because this 6 is always going to have at least one divisor or one factor, which is 2, and which is present in the array. Okay, and even if I talk about this 4, the same case is for with this 4. This 4 is never going to be a special number because this 4 has a factor which is 2, which is present in the array. Okay, what about this 15? This 15 again cannot be a like special number, so I can even eliminate the element from here, like this 4, this 6, this 4, this 15, because this 15 has a factor which is 2, at least one factor it has. Okay, now this is the largest number, so there are no any numbers which are greater than this 15. Fine. Now for this 5, okay, is there any number? No, there is no any number which is present in the array. Okay, so now I can surely say that there are three special numbers which are 2, 3, and 5. Now I hope you guys are getting the intuition. Like the intuition is, whether I check the multiple of the current number or I check the divisor, both means the same. So if any number is a multiple of the current number, then it is not going to be the special number in any case, because it will have at least one divisor, which is 2. Okay, fine. Now let me explain this. Like, let me talk about the approach now. This is about the intuition. So the approach is going to be, for every element, for every element, store its multiples. Store its multiples, right? So I'm going to store its multiples either in an array or in a set. I'll store in such a way that I can fetch any multiple in just O of one time. Is it possible? Yes, of course it's possible. Okay, so now I'm going to store these multiple in an array. Okay, and after that I will traverse this array and I will check whether the current multiple exists in here or not. So like for this two exist, I'm not going to consider these elements. Why? Because this is, if this 2 exists, then this is 2 itself. I cannot consider the same element itself. Okay, so this 2 doesn't exist, this 3 doesn't exist, this 6 exists, so I'm going to cross this. After this 15 exists, I'm going to cross this. After that, this 5 doesn't exist and this 4 exists. Okay, so this is what I'm going to do. Okay, now I hope the approach is also clear to you. Store its multiple for each element, and after that just run a for loop for and check for each element check uh, like check if it's present in factor array. Now one question you will ask me that, hey, I have to store its multiple, but till what value? Till which value? Like you can if I talk about the multiples of 2, so let me talk about the multiples of 2. So multiples 2 are like 4, 6, 8, 10, 12, 16, and so on up to like infinite values. So till which value I have to store? Let's see. Since in this array, if you notice that in this array the maximum element that we have was 15, so we are not going to check any value which is greater than 15. So I always need to store elements which are smaller than 15 or the largest element. Okay, so if I modify the approach, then I will have an array. You can even use the set for the same purpose, doesn't matter. I will use an array, and now in this array I will store whether the current factor exists or not. So how I will store, like if I have factor as 6, so I will make array of 6 as true, which means that 6 exists in the array, and I can fetch I can check for this 6 in just O of one time. Okay, like I will just check array of 6 value. Fine. Now one more thing is, the maximum value that I can have is the maximum element in the array, so max. So I need an array of size max plus 1. So I need an array of size max plus 1, isn't it? Now in this array, I am going to like store all the multiples. So how much time it will take? Like if I start from 4, each element, for each element. Okay, so in order to understand this, let's take an array which is having elements 1, 2, 3, 4 up to n. Okay, so first of all, I will have 1. Okay, let's not consider this one. I'll start with 2. Okay, so for this 2, I'm going to store all the elements like 2, 4, 6, 8, 10, isn't it? Up to m. M is the max element. Max. Okay, so I'll start a loop for j equals to 2 cross array of I, and again j is smaller than max equal to j smaller than equal to max, and j plus equals to array of I. This is how I'm going to have this series. Okay, now for this element I'm simply going to make array of j equals to 2, right? Okay, fine. So for the first iteration it will run m by 2 times, like if m is the max element, so it will run m by 2 times. Okay, and for the second iteration it will run m by 3 times, after that it will run m by 4 times, after that m by 5 times. So I'm going to have a series of 1 by x. Like if I take m common from these, so I will have 1 by 2 plus 1 by 3 plus 1 by 4. Okay, so this is a series of summation of series of 1 by x. So I equals to 0 to I smaller than m. Okay, if I integrate this value, then I will get log m, isn't it? Like integration, summation is nothing but integration. Like, so for smaller values I can write summation as integration. Okay, so if I sum up all these values, then it is going to give me log m. So this inner loop will run log m times. Okay, and the outer loop will run n times. So the complexity of this approach is going to be O of n log m. Okay, fine. Now I will show you the code, but before that I want to tell you one more thing, which is again handling duplicate elements, because here as well I can the same series as I have explained you here. Like I can have the same series for this condition as well. So I have to handle those elements. I have to handle those elements. Like if I have 5, 5, 5 and 5. So for this 5, it will store all the elements but not 5. So it will give me series like 10, but there is no element greater than 5. So it will not give me any series. For this, it will give me, it is not a like valid special number. Again, it is not a valid special number. So I have to handle cases like this. In order to handle this case, I have to check whether a current element occurs 2 times or not. So if it has frequency 2, in that case I will simply return like I will simply say okay, it is a valid special number. Why? Because I cannot consider element at this index, but I can consider other elements as well. Doesn't matter whether they are equal or not. So I have to consider this case. uh, it may be possible that initially this is not clear to you, but if you see the code, then it will be more clear to you. Okay, and now before okay, so now I'm going to show you the code for the Sieve method. Okay, so here I have the code. On the left hand side I have Java code, and again on the right hand side I have the C++ code. Okay, so I'm initializing the hash map. Hash map is again going to check whether I have the duplicate elements or not. Okay, and after that I will find the max value. Okay, and for max value I have made an array which is a factors array. Okay, and this array is going to store all the factors. Okay, and this is how I'm storing the factors, and along with this storing I'm also storing the values in the map, and also checking whether the current value is like I have to handle duplicates, right? So here I'm handling the duplicates. Okay, now at last I'm checking whether factors of I exist or not. But one more condition I'm checking, and this is what I have explained you. Like if you see here, then you will notice that this is what I have explained you. Like for cases like this, if the frequency, like for this it will give me false, like factor array will give me false. Okay, but this array but map will say okay, but it this element has a frequency greater than 1. So in that case I have to return true. Okay, so this is what I'm doing here. If you do the dry run, then you will understand more clearly. Now let me okay, so on the right hand side I have the C++ code, which is very similar to the Java code. Now I hope the problem statement and all the approaches are clear to you. So this is all about this video. Thank you.